Assalamualaikum warahmatullahi wabarakatuh. Good morning. Let me introduce myself. My name is Adi Prasetya. I'm from Diploma 3, 11 Maret University. And my study name is I83-15001. And today I want to explain to you about electrolysis. In chemistry and manufacturing, electrolysis is a technique that uses a direct electric current or DC to drive an otherwise non-spontaneous chemical reaction. Electrolysis is commercially important as a stage in the separation of element from natural occurring source such as ores using an electrolytic cell. The voltage that is needed for electrolysis to occur is called the composition potential. The main component required to achieve electrolysis are 1. An electrolyte, a substance, frequently an ion conducting polymer that contain free ions, which carry electric current in the electrolyte. If the ions are not mobile, as in a solid salt, then electrolysis cannot occur. 2. A direct current or DC electrical supply provides the energy necessary to create or discharge the ions in the electrolyte. Electric current is carried by electrons in the external circuit. 3. 2 electrodes, electrical conductor that provide the physical interface between the electrolyte and the electrical circuit that provides the energy. A liquid containing mobile ions electrolyte is produced by 1. Solvation or reaction of an ionic compound with a solvent such as water to produce mobile ion. An ionic compound is fused by heating. And now I want to explain to you about oxidation and reduction. Oxidation and reduction at the electrodes. 1. Oxidation of ions or natural molecules occurs at the anode. For example, it is possible to oxidize ferrous ion to ferric ions at the anode. 2. Reduction of ion or natural molecule occur at the cathode. It is possible to reduce ferrocyanide ions to ferrocyanide ions at the cathode. And now I want to explain to you about energy change during electrolysis. The amount of electrical energy that must be added equals the change in Gibbs free energy of the reaction plus the losses in the system. The losses can, in theory, be arbitrarily close to zero. So, the maximum thermodynamic efficiency equals enthalpy change divided by the free energy change of the reaction. In most cases, the electric input is large than an enthalpy change of the reaction. So, some energy is released in the form of heat. In some cases, for instance, in the electrolysis of steam into hydrogen and oxygen at high temperature. The opposite is true and heat energy is absorbed. This heat is absorbed from the surrounding, and the heating value of the produced hydrogen is higher than the electric input. And now I want to explain to you Faraday's law of electrolysis. First law of electrolysis. In 1832, Michael Faraday reported that the quantity of elements separated by passing an electric current through a molten or dissolved salt is proportional to quantity of electric charge passed through the circuit. This became the basis of the first law of electrolysis. Mass equals K time Q, or M equals E times Q, where is known as electrochemical equivalent of the metal deposit of the gas liberated at the electrode. Second law of electrolysis. Faraday discovered that when the same amount of current is passed through different electrolytes or elements connected in series, the mass of substance liberated or deposited at the electrodes is directly proportional to their equivalent weight. And now I want to explain to you about the whole Herald process for producing aluminum. 1. Electrometallurgy is the process of reduction of metal from metallic compounds to obtain the pure form of metal using electrolysis. Aluminum, lithium, sodium, potassium, magnesium, calcium, and in some cases copper are produced in this way. 2. Production of chlorine and sodium hydroxide. 3. Production of sodium chloride and potassium chloride. 4. Production of perfluorinated organic compounds such as 3-fluoroacetic acid by the process of electrochlorination. 5. Production of electrolytic copper as the cathode from refined copper of lower purity as an anode. Electrolysis has many other uses. 1. Production of oxygen for spacecraft and nuclear submarine. Electroplating is used in layer metal for fortify them. Electroplating is used in many industry from functional or decorative purpose, as in vehicle bodies and nickel scone. 3. Production of hydrogen for fuel using a cheap source of electric energy. 4. Electrolytic etching of metal surface like tools or knife with a permanent mark or logo. I think it's enough for me to explain about electrolysis, and see you.